Okay, so here we are back in the wind tunnel testing the FPV RC Mark 1 wingsuit and smoke on. There you go, we'll be looking for flight characteristics and to see if there's lift being generated. So you can see there the wing surfaces changing and FPV feed coming in from the head of the wingsuit man. And there you go, there he is from behind. The wind says he is at 16.2 kilometers an hour and it's all happening on this episode right now. Show, and we are your hosts. I'm Harry.
And I'm Richard. Thanks very much for joining in, and this is all about wingsuit testing in the wind tunnel.
Yes, that's the one. We are testing the Mark 1 design, comparing that to the Mark 3 on this episode.
That's right. So remember to go back and check out when we built the Mark 1.
Yes, right through the sewing process. We took you all the way through the parachute testing and all the good stuff, and then we also designed and made a wind tunnel on the channel and the Mark 3.
That's right, and we're going to compare results at the end of this episode against the Mark III.
There you go, so let's get into this episode. Thanks very much to our sponsors. Thank you once again for tuning in. If you haven't done already, make sure you hit the thumbs up button and the bell button. Let's get into it. Here we go, in 3, 2, 1, race. Okay, so here we are back in the wind tunnel, and you can see that the diffuser screens are positioned at this point, which is what we used on the last test on the Mark 3 version. But since we're going and working on the Mark 1, we're going to be moving it back to start our original test and get into see if there's lift being generated. So we'll need to get the scales out and remount this guy. Let's get into it. It's better.
At least you know it's a tight fit.
Yeah, it's a tight fit, alright. She's in.
Ready to go?
Yeah, I think so. Okay, so there you go. So the diffuser's back in, and now it's going to get the Mark 1. Gonna start putting this, mount this guy, and he's quite a large one actually. How big is he? He is the 160 kV 9626 from Hobby Wing.
That's right, it's the VTOL motor, isn't it?
Yep.
Was it 39:1?
That's the one, power ratio, and
12S.
12S, yes, and this is a 200 amp ESC. There you go, so big enough to do this job right now. And we're just going to...
It's worked out pretty well so far, right?
For the first test, yeah, for sure.
For the first wingsuit test, which was ironically not 1, it was 3.
Yeah, we start with the Mark 3, so yeah. And the bolts are going in. We're just going to tighten it up. Yeah, just tightening this little bolt up. Okay, so we're just going to be fitting this guy on here.
Thing suggested on one of the forums, I think, I can't remember whether it was on the episode or on a live stream, but they said you don't sit in the world of, you just change the direction.
True. So we'll be drawing it over the surface.
A sky full of starlights will carry you home. Your glow is both bright and soft. I want to heal you no matter how far.
We're just putting them back together into one piece.
There's a little Velcro that goes on the side, isn't there, on that arm?
Yeah. We managed to sew that in last time when we made the suit. It's a bit interesting one because when the wingsuit is deployed inside the wind tunnel, we'll be able to see if the air valve inlets are having any effect to inflate the suit. So it's all set, all ready to go. Okay, so just taping down the scales. So So it's in the same place as it was in the last test.
Mark 1's now mounted up the top there.
Here's at 0 degrees. You need to do a control to see what sort of value it is. 869, is that right?
869, yep.
So 869 is the number.
At 0 degrees.
At 0 degrees, so that's the control.
Tear me apart if you must. I don't care.
Nice and straight. Okay, so let's fire up the motors.
Control number of 873 recorded, and we're just going to fire up the engines now. What is it, engine? Okay, 873. Okay, so this is a faster test at 16.5 kilometers an hour. Richard's got a wind gauge over there, and as he increases it, he'll match what we've done in the previous test. And there's the wind tunnel going there. Yeah. 873, same number. There you go. So no change on that one. Is that what you were expecting, Richard?
Probably. Should we go a lot faster and see what happens? If there's any change.
25.2 kilometers an hour, any change? 874, 873, so no change.
Okay, so we're just checking to see if the 15 degrees is all lined up, so angle of attack that is. So basically, the higher at the front than it is at the back. And it seems to be pretty well there.
Here it's just coming out.
Okay, so 880 is what the
Control is, and then Richard's going to fire it up, and we're going to go to 12.6 kilometers an hour.
yeah, it's still good. 878. Is that any improvement?
Yeah, it's 2 grams less.
Okay, so it's generating lift. Yeah.
But a little bit is something. 880, that's what it was before too, wasn't it? Yeah. Okay, ready? We're going up to 2 different speeds, might as well.
So 16.5, 22.5. So 16.5 initially. Alrighty.
16.5.
Okay, and ready?
Okay, test number 2. Here we go.
Yeah, that's it. 87 what? 877, yeah. 877.
Yeah, there we go, yeah. 878.
We've got one more degree of angle of attack to do, which is the 30 degrees, which is there we go, it's at 30 degrees, so it's about right. But we can sort of say at this point in time that the Mark 1 is not as efficient as the Mark 3, which kind of makes sense because 1, it's slightly heavier, and 2, its surface area is a lot smaller because obviously that one's quite a bit bigger. So
It's what we were expecting.
it's what we were expecting.
And we'll put this one on here for the 30 degree test, and they could see how we could improve the Mark 1. So because ultimately that's what we want to see, is we want to see improvement.
That's right.
Yep. And then after this test we'll go into the smoke testing section to see visually is there any smoke lifted.
That's right.
Creating lift, and then we'll jump into
Control, that's right.
to
So
see can we
flight.
control it inside the wing.
That's right. Are the small surface area that we're having any effect on turning ability? And also, is it going straight or is it sort of yawing around? We'll find out in due course. Resetting it, so that means I got to tape it to the scales, but I got to do it in a way that means the scales can actually work. Yeah, so the parachute's on his back there. It's not just a backpack, it's in fact his parachute that goes with him. We've tested it before with that chute. Seemed to work okay.
12.5 kilometers an hour, 22.5 kilometers an hour, and 16.5 kilometers an hour, all at 30 degrees. And the weight is sitting at 888. Yep. Ready?
Okay, firing up in 3, 2, 1, go. 887. So it's just 1 gram.
Yeah, not much, but it's something. I've got another look over here. Okay, that's 886.
We're going to do the smoke test. as we did on the previous one, which is the Mark III. So we're continuing on with the same test, right? So this is at 0 degrees. We're going to add the smoke from this side. It's going to go through the diffuser, and then it's going to go over the wing surface, pull the air from that motor, the VTOL motor, over that end. So it's going to be a nice consistent pull all the way through. 0 degrees, 15 degrees, and 30 degrees. Plug it in. That's one. And there's the other battery. Good sound. Smoke on in 3, 2, 1.
Did you say that there was any lift being generated on that?
Pretty much straight through. There's probably quite a bit of drag from generated coming off his parachute. Yeah. And
it wasn't noticeable, was it?
No.
I didn't see any swirling action behind it.
15 degrees test. Okay, smoke on. In 3, 2, 1, smoke on.
Now, there might be a little bit.
There's a little bit, eh?
A little bit.
Swirling underneath the wing there, the back.
A little bit.
There, see?
Is it getting sucked? Oh yeah, you can see it getting pulled around it. I'm going to swap over to using the smoke wand, I guess you call it, and to see if we can get a bigger, a bit more accurate on it, so we can see. 2, 1, smoke on. You can see a little bit coming off there. A little bit rolling back around the back of them. So there is a little bit getting generated. Not heaps, but there is something. Getting the 30 degrees all sorted. Okay, so we're just going to tape that on and then we'll get into it. And that there will make the difference to make this a fair test, and that way the Mark 1 and Mark 3 can be tested fairly. Tape them in place and then you can get into this smoke test to check this 30 degrees to see is there lift being generated. So far I would say that there's not as much generated compared to the Mark 3, because the Mark III is a lot lighter and a lot more surface area, so it does make a lot more sense. But what we will be looking at is to see is there any lift generated, because it's a lot smaller.
Okay, so 12.5 tons now at 30 degrees incline. In 3, 2, 1. Yep.
And smoke on now.
Oh yeah, it's working.
You can see it rolling over the wing there. That's good to see. Smoke wand in. There it is there.
Okay, in 3, 2, 1.
Yeah, you can see it. There you go. So far the smoke trails off the back, looking at those videos, you can see that there was smoke being formed just like the Mark III. You can see there was smoke, and if you go back and have a look at the Mark III test results, you can see that there was smoke being generated, quite a lot more being generated off this one compared to this one, but it is expected because this one's a lot smaller in size. I just lifted up so you can see, but you could see that the smoke was hitting it and generating some lift, which is good to see. So the next test, we can put these aside, but what we'll be doing is we'll be setting up for the next test, and we'll be doing just like we did with this one, a control test, and we'll be hanging him from the roof of this guy, pushing that wall back, the diffuser back to where the propeller is up the end. Can you see the VTOL motor back there? And we'll be looking for linear flow, and we'll be adding a ramp in it just to be exactly the same as they do for indoor wingsuit flying. In this test, will we be able to control it? We'll be able to go right and left, and up and down and all those sorts. So let's get into it, readjust this guy and get into this test.
I want to heal you, no matter how far, because you are a sky full of stars. Tear me apart if you must, I don't care.
Putting the battery in.
Getting ready for this next
Test. Put that battery in there.
Okay, so we got the little guy here, the Mark 1, and he's ready for his first wind tunnel test. He's attached him to the hook. There you go. There you go. Now we're going to go and test flight, aren't we, Harry? Seeing how well it steers. Do the flaps have any effect when it's under wind, and basically when it's under flight? You know, elevator, does it work? Irons, does it work? And then also, do we need to add a stabilizer rudder, or is it fine as it is?
Heaven's view, my guiding star in the night.
Welcome to OpenTX.
Yeah, FPV's coming through.
Okay, so there it is there. She's working. Like again now.
Or minimal effects. That's the left of it there. And then we'll go up. That does have an effect. That did have an effect. Up. Elevator does have an effect. Down.
Okay. And what are we changing again? That's up.
It's up. So this is left. Oh, yeah, it does move a little bit, eh?
It's a little bit of movement.
A little bit of right.
You can feel it does move.
Oh, there we go. Yeah, so it is working, just not as well as it could do, right?
Can I see that?
So it is having an effect, but it could be improvement, right? So like you can see the wind is, because of the air's coming in through the air valves, it inflates the suit, makes it wider, right?
Yeah.
And then what's happening is the actual irons are having less effect. So what we need to do is we're going to need to tweak that so that way that it has more effect on what's happening. It is having some effect on it with the wing surfaces, not as much as we would like. So it's a good idea to, that's why we do a wind tunnel test in the first place, so you can tweak things. So because the air is going into the inlet valves, what's happening is it's inflating the suit, which is exactly what I wanted it to do. But the problem is it's inflating it, and then now the irons and elevator are sort of, it got longer to travel, right? Because they're inside the suit. So we're going to have to maybe thin the flaps, or we might have to add some adhesive on the inside for the material. So then that way the movement is more prominent. So Harry's firing up. We're going for a much higher speed. I've got the trusty wind meter in front of me. Off you go, Harry.
Like you?
So last time was like what, 16.5 kilometers an hour, something like that?
Yeah. Okay. That's the sound of the VTOL drone radar going up.
Okay, that's cool. 22.6, 23 kilometers an hour. Up. Yeah, up had an effect. Down had an effect. Yeah. It's to the right. That's to the left. And this is up. So you can see that there. That does have an effect there. It's porpoising.
done some modifications to the suit, so that way we might get a bit more flat movement from these arms.
Yeah, got that on, yeah. And what about the irons over there? Yeah, there's a bit more articulation.
And I'll turn the other side. Okay, sweet. So let's go and test it out. Let's try up. Oh yeah. Down. And right, that's right. Left. I'll just give him a spin, see what he does. Okay, that's an interesting thing, Richard. So there you go. So he is stabilizing when I do that. It does spin very easily like that. Okay, so we just have a look at stability. Oh, look at that. So it's quite stable. So it's sort of. So why do you think that is? I think it's actually straightening itself out. I think it's the pockets and the shape of the foil. So that's interesting. The shape of the wings. Yeah. So it's significantly stable. A little bit more stable than the Mark III, I'd say.
Yeah. Okay. So 0 this side, see?
Okay. So saying that, back to H&R Dream Racing HQ. And we're back. So there you go. There's the Mark I just sitting there. Cool. Okay, so what do you think, Richard? We did 3 tests on this experiment today in the wind tunnel, and what were they, Richard?
That's right. So the tests were lift, right? So we work out, is there lift generated under the wings? The second one was smoke. So smoke is a visual aid to see whether lift was being generated. Then the third one was flight characteristics.
Can we get control? And we also did another one too, which was stability in flight. There you go.
Which is technically the sort of under the same
like
sort of banner.
Subtitle. Yeah. So there you go. So breaking that down, let's look at the first one.
And we're going to compare it against the Mark III. So we're looking at the Mark I chart here. You can see that we did 3 speeds. They're 12.6 kilometers an hour, 16.5 kilometers an hour, and 22.5 kilometers an hour. We did that additional one just to see if there was any effect generated by adding more power, but it didn't seem to make too much of a difference. And angles of attack was 0, 15, and 30 degrees.
There you go. Yes, and we put that onto the scales, and we also did a control before each test. There you go, to get an even result.
That's right. So that's why you can see the weight before and the weight during.
Which is the one.
That's right.
So pretty much from the 0 degrees attack, you can see that pretty much it was 0
across the board.
How much force generated, and also you can see once we got into 15s and 30, there was basically 2 to 3 grams of force being
generated.
Yeah, 15 and 30 degrees, but not too much. So very small compared to the numbers that we were seeing in the Mark III design, which is good to see, because in the Mark III design you want to see improvement after all, don't you?
That's right, because obviously it's a later design, right?
A later design, whereas like comparing to the Mark III design, we were getting up to
significantly higher numbers here. So 0.38259 newtons. So it varied quite a bit, but you could say that yes, there was an improvement with force generated under the wing surfaces
in the Mark III.
From the Mark I to the Mark III.
That's expected.
That is to be expected.
That's the reason why we did it. Yeah.
That's right, but it is good to see it in figures. Okay, so let's move on to the smoke test. What would you
Okay, smoke trials test. Okay, so in this particular test, we were looking for visual aid to see, is there any lift being generated? Is there swirls coming off the back of them?
And you could see smoke coming in, going under the wing.
Yes.
Sort of going over the top, and then also when it's more the 15 and 30 degrees,
yes,
you could definitely see the smoke hitting the wing and then curling underneath, just like it should be, aka it's generating lift.
There you go. It might not be much, but it is moving. There you go.
Of course, you know, the surface area is a lot smaller. But they're falling with style, basically.
Pretty much, you're just a brick in the air and you're falling, and you can shape it a little bit, but the ratio is a lot less. So that's expected. So when we go to the real test, it could really perform. So there you go.
Yeah, just you'd have to go from a high altitude.
Yeah, exactly.
He's not going to be. He's not going to be gliding for.
It's not a chuck glider, but there you go. So that's it. That's good. That's good.
And that's what we wanted to know. So positive there, right?
Positive.
Okay, so moving on to the flight characteristics, stability, and are we getting aileron and elevator controls?
Okay, so we're definitely getting elevator controls up and down. We could see that the man was
dipping,
nodding his head, and you can see that was having some effect. But the arms still need a little bit more work to get the control surfaces to have a major effect. So maybe what we'll do is we'll go back in and add a bit of a stronger control horn.
There is some movement we can see, even with the little modification that we managed to do in this one, but not quite enough. It needs a little bit more. Because what was happening was air was going into the chute, and then it was expanding it, and then the ailerons were having even less effect. Right,
but on the pro side to that, very good stability in direction to the wind.
So that's right. So
that's a plus right there.
That's something that we were determining. These air valves are effectively acting like rudders, keeping it straight, keeping it nice.
Yeah,
which is quite different from the Mark III, where it only for straightness wise, it only had those.
You had to control it back into position.
So maybe something we should add to the Mark III design.
To improve that as possibly. Okay, so there you go. So that is the analysis of the Mark 1. So there's some pros and some cons there, but that's okay.
But mostly pros.
Mostly pros, yes. So we'll be looking forward to improving the design, and then we'll be looking into flight testing them for real. Okay, so moving on to the next segment on the show. The movie of the week is The Equalizer. Yes, with Denzel Washington. This is the remake version from the original version. Both are very cool, and it's just good to see the bad guys getting taken out. That's
right. He uses tools in the hardware store, right?
So watch out, bad guys. There you go. So that is the movie of the week that you should check out. Final thoughts for this one, Richard?
It was interesting to see how the wingsuit performed in the wind tunnel. Very interested in the stability of the air pockets. That was something that we did learn. Very cool. Very
cool feature right there, and just cool to see the manipulation of the surfaces. It's kind of cool like that.
It's quite a unique thing. Effectively, it's a fabric moving.
Man, there you go. So it's very cool. So there you go.
Cool concept.
Very shortly we'll be testing the Mark II design, so make sure you stick around for that one. Like, subscribe, and share. Thanks very much to all our sponsors. Couldn't do without you guys. Thank you once for tuning in. I'm Harry.
And I'm Richard.
And let's get into next week's episode. Join us on live streams and all the good stuff. In 3, 2, 1, go! Action!